Hello, this is Dr. Christy Patton-Lukes, a chemical engineering professor at Missouri S&T. We'll be looking more at reaction systems, and in this particular case, we're going to be looking at applying Gibbs phase rule to systems with multiple reactions. In this case, we have 4 reactions. H2 plus I2 makes 2HI. I2 can break up to 2 I atoms. I plus H2 makes HI plus H. H plus I2 makes HI plus I. And what we want to know is how many degrees of freedom would there be for this gas phase reaction network. Now, Gibbs phase rule tells us that the degrees of freedom is 2 plus the number of components minus the number of phases minus the number of independent reactions minus the number of restrictions. In this particular case, if we count, I have H2, I have I2, I have HI, I have I, and I have H, so I have 5 components possible. I have one phase, because this is a gas phase reaction, and gases always blend to a single phase. Liquids might form multiple phases. Solids typically do form multiple phases. I have no restrictions listed. The question, therefore, is what is the number of independent reactions so we can plug in our numbers and get an answer? To do this, we're going to use the rank of the matrix created by these reactions. In this case, my reactions I've recopied here. I've numbered them 1, 2, 3, and 4. And I'm going to set up the matrix with the compounds in the order shown. And so I need to put in my coefficients. Let's do the typical negatives for my reactants and positive for my products. Okay, so there's my basic setup. And remember that the rule says first put a 1 in the top location here. So to do that, what I want to do is multiply row 1 by negative 1. So that'll be 1, 1, negative 2, 0, 0. And I want zeros in the positions below that. So 0, negative 1, 0, 0, 2. I don't need to do anything to row 2, and I don't need to do anything to row 4. But for row 3, what I want to do is I want to take my new row 1 and add it to row 3. So 1 plus negative 1 is 0. 1 plus 0 is 1. Negative 2 plus 1 is negative 1. 0 plus 1 is 1. 0 plus negative 1 is negative 1. Okay. The next step, I want to, I'm not going to have to do anything to my top row. I want to have a 0 in the first position that's non-zero. So I'll divide by negative 1. 1, 0, 0, negative 2. And now I need to put zeros in the positions down here. So to do this first one, I'm going to take the old row 2 and add it to the old row 3. So 0, 0, negative 1, 1, 1. And for the other one, I'm going to take row Well, I can do this a lot of different ways, but let me just do 3 and 4. If I add row 3 to row 4, I get 0, 0, 0, 0, and 0. So I now have this as upper triangular. I count. This is 1, 2, based on the ones. I could make that divide by -1 if I wanted to. 3. And this one doesn't have any, so therefore I don't count that. The rank is 3. So therefore the number of independent reactions is 3. Therefore the degrees of freedom is 2 plus 5 components minus 1 phase minus 3 reactions minus 0 because I have no restrictions. So 7 minus 4, degrees of freedom is 3. So I could specify 3 things in order to have a completely specified problem. So what might those be? Maybe temperature and pressure. I still need one more. So how about the ratio of H2 to I2 in my feed? This is a possibility of what those 3 degrees of freedom might be. Thank you very much for your time.